If x is 0, what's 0.53 to the 0? 1. 1 times 267? 267, boom, there's your y-intercept. Yeah, so that's one of those things I want, it's one of those lessons you'll learn in like 30 seconds in Math 65. And I hate that, because I want you to immerse yourself in the pattern finding, because that's why it is what it is. So, fair? Okay, so if it's where x equals 0, if you remember our data, put the data back up here real quick. If you remember our data, I put, this is x, right? This is x and this is y. Essentially, it's our data x and our data y versus our model x and our model y. Remember it was 289 with our data, but it's 267 with our curve. Why is it off? Good. Essentially, yes, it's a best fit curve, not a perfect fit curve. It's a best fit curve, not a perfect fit curve. Just like when we made best fit lines and best fit parabolas, they didn't exactly hit the points, did they? They came damn close. It's that whole least squares idea. It misses the least. It misses the points the least. So you might say to yourself, well, hell, it's 267, that's off by a lot. But look at it. Look. Is it really? There's the point right there. There's your two 89s right up there. It's not really missing it all that much. And it's definitely catching the other points very, very closely. So if you had to adjust the curve to catch the first point more, you'd screw up the rest of it. And you'd create more error. So the mathematics takes care of that balancing, that averaging for you. So, can we talk about what this number represents right here, kind of in general terms? If you had to tell me what that 267 meant, you know what, one thing first, sorry. Hold that thought. I want to define my variables. X and Y. What does X stand for in here? It's the same X that we put into our TIs to get the model.
Number of flips.
It's a number of flips, isn't it? It's a number of flips. It's a number of flips. That was like flips, though. Flips. Number of flips. X is number of flips. 0, 1, 2, 3, 4, 5. Up to 9. Technically speaking, they should go higher than 9. If I had you guys do the experiment more and more, eventually somebody would take 10, somebody would take 11, somebody would take 12. The curve goes on forever that way, mathematically. Somebody could theoretically take 2, somebody could have started on Wednesday and still be flipping now. Kill me. Kill me. I mean, honestly, right? That could happen, theoretically. It just is not likely to happen, probabilistically. What's Y? Number of people. Good. Number of people. And the number of people in particular that took that many flips to stop. But I'm going to leave it at number of people because we're going to edit the cards to make it match your quiz better for this week. So I was thinking about it on Wednesday. We'll come back to that. So, let's see if we can make sure we understand what the 267 is. We know it's the y-intercept. That's the mathematics. Or it's the mathematical explanation of what it is. What is it contextually in this data right here?
Number of people that started.
Beautiful, Carrie. It's the number of people that started the experiment. Does everybody follow that? Now you know it's 289, don't you? But if somebody just gave you that equation and said this is the best fit model, you would just predict it must have been 267. And you know that that's not going to be perfect because it's a best fit curve. But you know it's close to 267. So yeah, in mathematics it's often called the initial amount. I have a hard time spelling today, I apologize. Initial starts with an I, not an N. Initial. Good Lord. Initial amount. In this case, it's the number of people that started the experiment. Good! What's this? Let's use a different color. Because this is where it gets fun. This is how I was recently, I say recently, it's been about 4 years now. I got hired, not hired, I asked to do a favor for the Ben PD, where they wanted to come down and do some modeling of crime rates based on certain factors. And I ended up doing a bunch of exponential modeling for them. It worked out really well. Exponential modeling worked out really well. And I had to teach them what that, they got this like that. I think most students of mathematics or non-mathematics will get that after this little discussion we just had pretty quickly. But that took them a while. So how would you explain it to the Ben PD with a 0.53 is? A placeholder of what? I love that, by the way. Placeholder of what?
The amount of flips you're going to be taking on average.
I'll give you a hint. It's not an amount. It's not an amount. It's a percent. That's why it's decimal 2 places. Actually, it's decimal to like a whole bunch of places. I pulled it to 2 places. It's a percent, and it's not perfect. It's the best fit. Michelle, what are you seeing?
Percent of the time that you hit. That's
It's the percent. It's the percent of. I like to call it this. This is my own language. Okay, this is not really mathematical. What it's called is it's either called percent growth or percent decay. This would be a decay, not a growth. Why would we call this decay? Remember the curve? How the curve was shaped? It's exactly fit. It's dropping as it goes to the right. It's decaying. It's getting smaller. So what this is, I like to call this the maintenance rate. It's the maintenance rate. And the reason I call it that is it's maintaining the amount at 50% of whatever it was before. It's maintaining the previous amount by 50% each time. Do you see how we're losing essentially half of the people each time? We're setting the rate at about 50. The model said 53%, not 50. But it's a best fit model, right? It's a best fit, not a perfect fit model. It's close to 50%. The perfect rate should have been 50%. Why do I keep saying 50%? Where am I pulling this number out of? Remember what they were doing? They were flipping coins. Flipping coins have 2 outcomes, heads and tails. Half the time it's yes, and those half that flipped heads are gone. They stop flipping then, correct? The 50% that have tails keep going and flip again. That's the maintenance. You're maintaining it at 50%, or in this case 53%, but it's close to 50%. That's the idea. So I like to think of it as the maintenance rate. You can set the maintenance rate. You can set the maintenance rate for any function and then have it behave with that. Why did I use this for the Ben PD? Whenever you talk about populations changing, they often use percentage of growth. The United States, Ben. Ben doubled in population between blah and blah. That's exponential growth. It doubled. 200%. That's a rate, isn't it? 200%. They didn't say we added 40,000 people. They said we doubled. That's different. That's different.
So if you just go with the numbers of like the number of people and their flips, line L and
Yes.
L2. So basically, if you're going on those numbers, it's saying like after the first people, 132 of them flipped.
Yes.
Only 75% kept going, and then from that point.
Hang on, hold that thought. I love what you're saying. Tammy, yes. So if you think of it this way, now our data isn't set up exactly like you're describing.